G'day, welcome to the second video in the series on compound and double angle formulas. In the previous video we focused on compound angle formulas, and in this one I want to focus more on double angle formulas. Again, I'm going to show you how they come about and why they're there, but essentially really all you need to know is how to use the formulas and manipulate them in different ways. But it's always fun to know stuff. So, how do we get this? Sine of 2u. I don't necessarily know what that means, but I can turn that into sine of u plus u. Yep, 2u, same as u plus u. And now I can go back and I can use my compound angle formulas, which says, I'll just get them up here so you remember them. You remember seeing them anyway. So we're looking at this one here, number 1. Okay? So sine of u times cos of u, because they're both the same, plus sine of u, well it's actually cos of u, sine of u actually, cos u, sine u. Okay, now essentially these two are exactly the same thing. One multiplied by the other is the same as the other multiplied by the other. So we have 2 sine u cos u. And that's one of the formulas that you need to know. So sine of 2u is actually equal to 2 sine u cos u. Again, I could show you using, say, sine of 60. That's the same as sine of 30 plus 30. Sorry, not 30 plus 30. 30 plus 30, which is the same as 2 sine u cos u, or like I can do the whole formula if you want to see that. So sine of 30 cos of 30 plus cos of 30 sine of 30. Get our special triangles, that's a half multiplied by root 3 on 2 plus root 3 on 2 plus a half. And I've got root 3 on 4 plus root 3 on 4, which is root 3, or 2 root 3 on 4, which is root 3 on 2, and sine of 60 is actually root 3 on 2. So this formula here is proved, and it works. Let's have a look at this one here. So cos of 2u, what does that equal? I'll bring it down a little bit so we've got a bit more space. Now again, I could make this a bunch of different ways, but I'm going to make it cos of u plus, I did it again, the plus has got to be inside the bracket like that, and that turns into cos u minus sine u sine u. Okay, and that's the same as cos squared u minus sine squared u. And you can leave it like that if you want to, but there are other things that you could do to that as well. You could turn cos squared u into 1 minus sine squared. So you get this. Sorry, the reason I did that is because cos squared u plus sine squared u is equal to 1. So cos squared u is the same as 1 minus sine squared u. Okay, so you could do that. And then you get 1 minus 2 sine squared u. So this is good. This is good. Or you could do the other way around. You could make it sine squared u is equal to 1 minus cos squared u. And you end up getting, so going back up to this one again, so I drag that one down, I get cos squared u minus 1 minus cos squared u. And that ends up being cos squared u, or actually 2 of them, minus 1. It's another formula that can work as well. So with this, we can actually get a whole range of different formulas, or a whole range of playing around with things. And so I guess for double angle formulas, you need to remember a few things, but bear in mind that you can combine all of these things and prove a whole bunch of crazy stuff. So there's thousands of rules that we could learn, but we're going to restrict it to the ones you learnt in the previous video, and these ones here in the green. So the proof of them is just underneath, but these are the double angle formulas. So cos 2u is equal to all of these things. This is what we did before. or sine 2u is equal to 2 sine u cos u, and tan 2u is, I didn't prove the tan one, but you can have a look at it yourself if you want to, is 2 tan u over 1 minus tan squared u. Okay, so all you need to know is the stuff in the green boxes. But it's nice to know all that other stuff. It's cool to have a play around with all this stuff. You know, it's a good party trick. Anyway, in summary, what you need to know is all of these formulas here. The more you know them, the easier it is to apply them, and easier it is to kind of think on your feet a little bit, just like knowing your times tables helps you to do fractions a little bit better. So all of these things you need to somehow commit to memory. I would suggest just using them a lot, that way they're committed to memory, or have little tricks of trying to understand them, writing on flashcards or you know, wherever else. But that concludes the videos on compound and double angle formulas, and I hope that it's made a lot of sense. If not, please let me know. Thanks.